So after we discuss about the array implementation, now we want to take a look of the linked list implementation. Before we move into the linked list implementation, I want to remind you guys about the pointers concept. So if we look into this very simple, straightforward pointer program, you should be able to understand the basic part of it. So using a namespace std including iostream inside the main function, first of all, when we try to define a variable, say var equals to 20, what will happen in operating system is that it will go into a memory. So assuming this is our memory, starting from the 0 location to all the memory space that I have, say 8 gigabytes. So what it will do is that it will look into the address, finding one space that's available that can store an integer, because we define it as an integer variable. So saying that it look for the address like this one, very ugly, nested, understandable value. That's usually what happens for the address if we really look into. And then you go into that address and then store the value of 20. And now variable var is located at this address. Next, if we try to define a pointer indicating that we want to use this address to store the variable to store the address, now saying that IP equals to the address of a var variable. So now we are assigning this ugly address into the IP variable. So now saying that if we want to see out the variable, of course it will output the value of that. If I want to output the IP, which is the address of the variable located, which it will output this whole address because that's the IP equals to. Saying that I want to look into the value that stores this address, it will then go into the value of 20. And therefore the output will be exactly like this way. So this is try to remind you of the ideas of what's the address and the values that we're looking at. If we try to map that with something you already know, this is actually a simplified memory address. Of course, in order to use for the class, I usually like to use very simple understandable address, but of course you see that this is a very small space of the address. It's go all the way back to 8 gigabyte, 12 gigabyte, or 16 gigabyte, but I just simplify the address, saying that the memory looks like this very small teeny tiny memory. When we try to define an array, what's happening is that the operating system will look into your definition. For example, I say int, I need integer space of array, and I need 10 spaces. So what operating system will do is that you will go into the memory, try to find a location, say 4, that can reserve 10 spaces from 4 to 13 basically. So that saying that this chunk of the space are available, so it will keep it reserved, so nobody can touch this space. When the array is being accessed, what operating system will do is that it will understand the first location is 4 in the address of 4, and that is corresponding to the very first item. So the array in our mind, saying that this array has 5 elements and it has 10 spaces. So that array in our mind, starting with the first location, give a value of 9, 17, 22, 26, and 34. So in memory, they are actually stored in a continuous space like this way. That explains you why we always start our index as 0, because that is the exact location where the array starts, so that it does not need to add any value. First location is the address plus 0, indicating the very first location. The next item is stored in the address of the array, starting with 4, and in the next location, which is plus 1, so you will go to the address of 5 to store the next item. And that is what's the mapping of the memory space with our array in our mind. By understanding that, you will see all the array are stored in a continuous space. That's why when we try to do the insert and delete, we need to shift the items that we have stored over there. Of course, the linked list implementation is try to avoid this cost. So let's take a look of the linked list. What linked list trying to do It's actually not something super difficult. It's a combination of the two things. So what it will do is that it will define a class called node. So everything inside of the linked list, it consists of two parts. The first part is about the data. The next part is an address. What that address tries to talk is where is the next item address is going to be, so that you will know the first item is in this location, so this is the value, and I'm going into the memory space to look for the next item, and the address is stored in the second part of it. Therefore, when we define this, whenever we try to declare a node, it will reserve a space not only for the integer data part, but also an address. So let's take a look at the memory now. So in the memory, there are going to be quite a few different addresses available over there. And for each address, it will consist of the data part as well as the next part. In the beginning, if we don't have anything, we will have a top variable to tell us where is the first item's address going to be. If we have nothing over here, top equals to null. That is the key thing for us to implement our empty function. So saying that if we try to insert the very first item, and that item say 9, indicating the value of the items we want to insert, and we want to insert that as the very first item. So we use 0 to indicating it's going to be our very first item. So in this linked list right now, after we successfully insert it, we will have one item, and that's 9. So what it will represent is this one. When it look into the insert operation, again, operating system will randomly go into the memory address, find one location. It can be 0, it can be 3, it can be 7, it can be 8, it can be 9. In this example that I generate, just saying that it has randomly decided goes to the location of 8 as the address. So in this case, what's happening over here is that it will look into the address of A, and then what it will do is in the data part, because the value of 9 is something we want to store, so we will put a 9 over here. And because we only have one item right now, so what it should do is next part will equal to null, -1, indicating that there is no next item, and indicating this is the end of it. Of course, you need to have a variable top indicating that where is the first item going to be. In this example, the very first item top equals to A, which provides the address of the first item's location. Saying that after this item, we want to insert one more item after the 9, which is the very first item, say 17, 1, indicating this one to be stored in the location of 1, which is the second, basically the second location. Again, operating system will go into the memory, try to find an available space. Notice that it is possible to look into the A location, but operating system will realize, hey, wait, this is not available, so it will randomly choose another location. In this example, it randomly try to choose the location of 2, which is available over here. So what's happening here is that it will store the value of 17 over here. But the question is, how do we link the two things together? Because we are looking at a list problem. The very first item of the list is 9. The next item is going to be 17, which is the one that we insert over here. So what you will need to do is that it will look into the first item, understand the first item is 9, and now it needs to change the next item's address, indicating that the next item is located at address of 2, so that it will link them together. In the address of 2, the next item is 17, and when we see -1 indicating it is the end of the linked list. So that's what's happening after we try to store the next item. Now, if we look into one more, so that if we want to store one more item, the first item is located at 9, at A address, store the value of 9. The next location is going to be 2, and then the data is 17. The important thing is this: if we try to insert one more item, operating system will randomly try to select a location that's available. So say in this case 7 address is the location. The next part of the second item will be 7, so it will link to this location. 22 is here, indicating this is the end. So you can see that we try to insert the items one by one to each other. The same example over here, say 34, then we will insert the value of 34. The next, so we will keep starting for the location of A equals to 9, go to the next location, 17, goes to the next location, 7, goes to the next location, 0. So this is the new location selected by the operating system. So all of the things are linked together. Of course, if you notice, right now we are looking into a very straightforward approach. We insert one items at a time, and each one is going to connect to each other, so that it is totally possible. Instead of inserting the next item, say 4 as the position, we can insert the next item as the position of 3. So that what's trying to say is that the first item is going to be 9. The next item is going to be 17, and the next item is 22. So now I want to insert my next item as 26. It will randomly select a location 6 over here. So this one will connect to 6, put 26 over here, and then you need to connect to the original next item, which is located at address of 0, so that you can insert something into the linked list. In this way, we are presenting the whole linked list in this concept. So you can see that for the top over here is indicating where the first item is going to be, and then we'll look into the next item, looks into the next item, and which is 26, the one that we just inserted, and then the next item. So that in this case, they will be linked all together. The last item would be a -1. The data part will store the data that we're looking into. The next part will indicating where's the address to store the next item. So by looking into this way, it gives you an idea what is a linked list. Of course, we will have program, we will have code to look into every single items to understand how does the everything going to work. So by using the idea of AET, abstract data type, we want to look into all of these functions. The first 3 are very straightforward, so I'm going to cover that. The insert, the constructor, empty, and display are easier one. Insert and delete deserve more time to discuss. For the constructor, it's super easy. As long as you create a variable top and make it to null, that's it. So that you can have an initial starting point indicating top equal to null, and then by doing so, you have initiated the space. So this is all you do. Create a constructor, top equal to null, and that the job is done for constructor. Because of that, the empty function is as simple as if top equal to null, then it is empty. Otherwise, if the top located in some address, then it has some new locations to start with. Traverse is going to be a more interesting one. Traverse is the one that you want to walk through from the beginning to the end of it, and then print it out every single items that we have. So if we use the same ideas that we have looked into, we will have to use a top pointer point at the beginning, and then we need to have a temp pointer to walk through all the items one by one, because top can never move. This is the most important variable, tell you where to look your linked list. So you don't change this location, you don't move top to the next, otherwise in this case you will never be find where the initial space is going to be. So what you will need to do is initially you have a temp variable equals to top, and then you use the temp to walk through each items one by one. So in our next video, we will look into this in detail and then try to see how does the code of Traverse can help us print it out every single items that we have over here.